Hi, I'm Joseph Smith, Chief of Software at Gears Inc. We programmed our robots in Simulink so we could make use of its simulation mode and graphic interface. All our robots' controls are linked to a gamepad simulator block, allowing us to test the controls with the Logitech gamepad. We also use virtual dashboard buttons throughout the program, as well as display blocks to monitor all numeric values. As one of our robot drivers is left-handed, we included a left-handed control option, which sends a signal to switch the controls from the right side to the left side of the gamepad. Our precision mode button sends a signal to slow down certain functions for more precise control. Our robot is made up of three subsystems. The first is the Propulsion subsystem, which uses a joystick to control the motors powering our robot's two wheels. This switch block reduces the speed in half if the precision mode is activated. We also added a function to reverse the direction of the robot's movement. This allows the controls to remain the same when the robot is turned around to be placed on the opposite side of the field. It is activated by a combination of three buttons to prevent accidental activation. It uses a state flow chart to determine if the buttons have been pressed in the correct order, then outputs a signal to a switch block, which, based on the signal's value, switches the propulsion between normal and reversed. This state flow chart also sends a signal that temporarily deactivates any uses of the three propulsion reversal buttons elsewhere in the model, so they will not be triggered while the propulsion reverse is being activated. The subsystem also includes a pair of buttons that cause the robot to move forward or backward autonomously until a limit switch is activated. This feature was tested in simulation to verify that the idea would work. Due to changes to our strategy, it was not used in our final robot, but it was kept in the Simulink model for future improvements. Next is the Turntable subsystem, which rotates the turntable on which our robot's arm is mounted. It uses a gamepad joystick to control the motor that rotates the turntable. This switch block reduces the speed by 1/4 if the precision mode is activated. We also added the capability for the turntable's rotation to be restricted by a pair of limit switches. Though it was decided that this feature was not necessary on our final robot, we elected to keep it in the model in case it is needed in the future. Finally, we have the arm subsystem, which moves our robot's arm up and down as well as controlling the wrist joint and the claw. Two gamepad buttons control the arm motor, moving it at half speed for maximum torque. This switch block reduces the speed by half again if the precision mode is activated. Additionally, we added a function that used electric wire sensors to automatically move the arm to predetermined positions. This feature was not implemented on our final robot due to strategy changes, but was left in the Simulink model for future enhancements. Our robot's claw is powered by two servos. A state flow chart based on the input of a single button toggles between the claw's open and closed positions. A wrist joint, also powered by two servos, was implemented on the robot to control the position of the claw. The wrist was programmed with three specified positions for different tasks. The state flow chart uses the input of the two gamepad buttons to determine the position value to send to the wrist servos. This concludes the presentation of our Simulink model. Thank you for watching.